The National Electrical Code, or NEC, sets the standard for safe electrical installations. Section 230.90b of the 2020 NEC addresses the number of overcurrent devices permitted between the building or structure disconnecting means and the service equipment. This section specifically states that there shall not be more than 6 overcurrent devices. This is a critical safety measure designed to protect the electrical system from overloads and short circuits. Let's consider a residential electrical service. In a typical setup, you have a meter, which measures the electrical consumption of the home. On the load side of the meter, which is the side that feeds power to the house, there may be an overcurrent device such as a circuit breaker. This breaker protects the service conductors from overcurrents. Then, the service conductors run to the service panel, which is typically located inside the house. The service panel contains the main breaker, which acts as the main disconnect for the entire electrical system. The main breaker also provides overcurrent protection for the panel itself. The NEC requirement of no more than 6 overcurrent devices between the disconnecting means and the service equipment is important for several reasons. Firstly, it prevents excessive series overcurrent protection. Too many overcurrent devices in series can lead to nuisance tripping, where a breaker trips unnecessarily, interrupting power to the house. Secondly, it simplifies coordination of overcurrent devices. Coordination ensures that the overcurrent device closest to the fault trips first, minimizing the extent of the outage. Thirdly, it makes it easier to troubleshoot electrical problems. With fewer overcurrent devices to check, it is easier to identify the source of an electrical issue. Now let's analyze a specific scenario. Suppose there is a 200 amp service with a 200 amp circuit breaker on the load side of the meter. This breaker feeds a panel with a 200 amp main breaker. In this case, there are 2 overcurrent devices between the meter and the service panel. The first is the 200 amp breaker at the meter, and the second is the 200 amp main breaker in the service panel. According to NEC section 230.90b, this installation is compliant because it has fewer than 6 overcurrent devices. In fact, it has only 2. Some people may be concerned about having 2 overcurrent devices in series, but this is a common and acceptable practice when done correctly. The key is to ensure that the overcurrent devices are properly sized and coordinated. The overcurrent devices must be rated to interrupt the available fault current at their location. The available fault current is the amount of current that would flow during a short circuit. It is important to consult with a qualified electrician to determine the available fault current and select appropriately rated overcurrent devices. In the scenario described above, the 200 amp breaker at the meter and the 200 amp main breaker in the service panel should be sized to protect the service conductors in the service panel, respectively. If the home inspector raised concerns about this installation, it is important to clarify that the installation meets the NEC requirements. The NEC allows for multiple overcurrent devices as long as the total number does not exceed 6 and the devices are properly sized and coordinated. Here are some additional considerations regarding overcurrent protection. Firstly, the service conductors must be protected from overcurrent. The size of the overcurrent device should not exceed the ampacity of the service conductors. The ampacity is the maximum current carrying capacity of a conductor. Secondly, the service panel must be protected from overcurrent. The main breaker in the service panel should be sized to protect the panel's busbars, which are the conductive bars that distribute power to the branch circuits. Thirdly, the branch circuits must be protected from overcurrent. Each branch circuit should have its own overcurrent device, such as a circuit breaker or fuse, that is sized to protect the circuit conductors and the connected loads. In addition to the NEC requirements, local codes and regulations may also apply. It is important to check with the local electrical inspector to ensure that the installation complies with all applicable requirements. In conclusion, the NEC permits more than 1 overcurrent device between the meter and the service panel in a residential installation, provided that the total number of overcurrent devices does not exceed 6. In the specific scenario described, where there is a 200 amp breaker at the meter and a 200 amp main breaker in the service panel, the installation meets the NEC requirements. It is still important to ensure that the overcurrent devices are properly sized and coordinated and that the installation complies with all applicable codes and regulations. Remember, electrical work can be dangerous, so it is always best to consult with a qualified electrician. Here are some examples of other scenarios and how they relate to NEC section 230.90b. 1. A residential service has a meter, a 100 amp breaker at the meter, and a 100 amp main breaker in the service panel. This installation has two overcurrent devices, which is compliant with NEC section 230.90b. 2. A residential service has a meter, a 200 amp breaker at the meter, a 100 amp subpanel fed from the main service panel, and a 100 amp main breaker in the subpanel. This installation has three overcurrent devices between the meter and the subpanel's main breaker, the 200 amp breaker at the meter, the main breaker in the main service panel, and the 100 amp main breaker in the subpanel. This is still compliant with NEC section 230.90b. 3. A large commercial building has a service entrance with multiple service disconnects. Each service disconnect has its own overcurrent device. As long as the total number of overcurrent devices between the service entrance and the load does not exceed 6, the installation is compliant with NEC section 230.90b. 4. An apartment building has a master meter and individual meters for each apartment. Each apartment has its own breaker panel with a main breaker. The number of overcurrent devices between the master meter and each apartment's main breaker must not exceed 6. Let's delve a bit deeper into some of the technical aspects. Firstly, understanding the difference between overloads and short circuits is crucial. An overload occurs when the current in a circuit exceeds the rated ampacity of the conductors or devices. Overloads can be caused by excessive loads connected to a circuit or by malfunctioning equipment. A short circuit, on the other hand, is an unintended low resistance path for current to flow. Short circuits can be caused by damaged insulation, loose connections, or accidental contact between conductors. Overcurrent devices protect against both overloads and short circuits. Secondly, the interrupting rating of an overcurrent device is a critical parameter. The interrupting rating is the maximum amount of fault current that the device can safely interrupt without failing. Overcurrent devices must have an interrupting rating that is equal to or greater than the available fault current at the location. Thirdly, selective coordination is an advanced concept in overcurrent protection. Selective coordination involves designing the overcurrent protection system so that the overcurrent device closest to the fault trips first, minimizing the extent of the outage. Selective coordination is particularly important in critical facilities such as hospitals and data centers. In addition to circuit breakers and fuses, other types of overcurrent devices include motor overload relays and ground fault circuit interrupters, or GFCIs. Motor overload relays protect motors from overheating due to overloads. GFCIs protect people from electric shock by detecting ground faults. Regarding NEC section 230.90b, it's essential to understand the definition of service equipment. Service equipment includes the main disconnecting means, overcurrent protection, and other devices used to control and protect the electrical service. The service equipment is typically located near the point where the service conductors enter the building. Furthermore, it's important to note that the NEC is a minimum standard. Local codes and regulations may impose more stringent requirements. Always consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. When performing electrical work, always follow safe work practices. To energize the circuit before working on it, use insulated tools and wear appropriate personal protective equipment, or PP. If you are not qualified to perform electrical work, hire a licensed electrician. Additionally, consider the importance of arc flash protection. An arc flash is a dangerous electrical explosion that can occur during a short circuit. Arc flash can cause severe burns, injuries, and even death. Electrical workers should wear arc-rated clothing and PPE to protect themselves from arc flash hazards. The NEC contains requirements for arc flash hazard assessments and arc flash protection. Furthermore, The grounding and bonding of electrical systems is essential for safety. Grounding provides a low impedance path for fault current to flow back to the source, allowing the overcurrent device to trip and clear the fault. Bonding connects all metal parts of the electrical system together to create an equipotential plane, reducing the risk of electric shock. Let's also discuss surge protection. Surge protective devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes and other transient events. SPD should be installed at the service entrance and at sensitive electronic equipment. Furthermore, consider energy efficiency. Use energy-efficient lighting, appliances, and equipment to reduce energy consumption and save money. The NEC contains requirements for energy-efficient electrical design. The NEC is constantly evolving to keep up with new technologies and safety concerns. It's important to stay up to date with the latest edition of the NEC and any applicable local codes and regulations. The National Fire Protection Association, or NFPA, publishes the NEC. The NEC is updated every 3 years. In conclusion, understanding NEC Section 230.90b and the requirements for overcurrent protection is essential for ensuring the safety and reliability of electrical systems. Always consult with a qualified electrician to perform electrical work and ensure compliance with all applicable codes and regulations. Remember that electrical safety is everyone's responsibility.